My name is Patrick Kettner. I'm here today to talk to you about progressive web apps. Out of curiosity, anybody here built a progressive web app before? Awesome, we're in for some fun then. So you might be asking yourself, what the hell are they? So hopefully I can explain them. I'm one of the members of the Edge team out at Microsoft in Redmond, where we help define a lot of the specifications that go into progressive web apps, and we'll soon be shipping Edge 16, which contains most of the APIs required to do it. If you try and find me online, you'll look at this photo. Besides my shirt, I promise you I do work at Microsoft. That's just kind of a thing my partner does for me every year for my birthday. She bakes me a cake. Normally she'd be here, but right now she's out in the States with our son. And he's a really cool kid. He was our first kid. And he's super, super happy. He was the easiest baby I've ever dealt with in my life. He actually went to the hospital with like 105-degree fever and looked like that. He's fine. There's nothing wrong with him now. But even when he's incredibly sick, they almost wouldn't admit him because he's happy all the time. He's now a lumberjack, which we're from Seattle. Those are the two options that are available: our web developer, or lumberjack. Yeah. So anyway, the one thing that always kind of bums him out though is whenever we get him into a car. I don't know, maybe something about being like restrained or something just really freaks him out and he just screams and panics. Otherwise, he's happy all the time. But after a few months of being at home constantly, we kind of got a little stir crazy. So we wanted to go up to the mountains up in Vancouver in Canada. I'm from Seattle, which if you're unfamiliar is right there in the States. Vancouver's just about a 2-hour drive north. And preparing ourselves, knowing that he was going to kind of freak out for being in the car for a few hours, I did what most nerds do, and you go online and you try and figure out what other people say you should do. And it led me to this video, which seems like nothing. It's just a whole bunch of dots, but for whatever reason, it hypnotizes the kid. You can seriously, if you have children in your life or something, try Googling, look up like calm a baby or something on YouTube and you'll find this video. It's crazy, it's magic, it works really, really well. He can be freaking out, barely being able to breathe because he's screaming so loud. I put it in front of him with a half a second, he just snaps out of it and stares at it. So, we get in the car and he starts freaking out and I show it to him and I win. And we drive up and we go. It's a really relaxing and enjoying drive. It was a beautiful day. It was back in the winter. And we, he was excited about all the different snow and everything. And we went and saw the scenes. And then, after we had been there for a few hours, we decided, it was about time to go home. It's a 3-hour drive back. And, we get in the car and we're up in Canada. And I pull up my phone to, calm him down, knowing he's about to freak out. He starts freaking out, and my phone does this. And it keeps doing this. And the reason is because I have incredibly slow cell service in Canada compared to home, and I'm trying to load a 45-megabyte video. And so I'm just really angry because all of a sudden, my kid's freaking out. Katrina, my partner's all angry at me because I said I would, not let this happen. And everything's going really stressful. I'm just really angry because, this 2G connection completely ruined my day. And, I'm just, like, everything was just, it doesn't matter if we had fun or not. It was the fact that the internet's slow now and I'm just pissed off and everything's, and, eventually we get going and we cross the border and on my phone, it suddenly starts working. And, I realized at that second that it's not that 2G ruined my day. It was the fact that I tried to load a 45-megabyte video that ruined my day. I didn't think ahead. I was perfectly comfortable with the solution that I had created in my home with really fast internet where everything was great. But as soon as I went to another experience that I had slow internet, everything was terrible. There's no reason that this has to be 45 megabytes. Like, it's a whole bunch of dots dancing. Anybody can build this, right? And that's exactly what I told myself, that I could have done this better. I'm just ashamed as a developer. So I drive home, get my kid to bed, and I open up a text editor, and I just stare at it for a really long time because I realize I have no idea how to make a whole bunch of circles in SVG. Whenever I get into this situation, I remind myself of, if you don't have a better idea, you just buy a novelty domain. And that's what I did. I bought Hush Little Baby. Now, if you go to Hush Little Baby, you'll see this, which is less than 6 kilobyte version in SVG, because eventually I was able to figure out that you can just create a circle by writing the word circle and animating it, and everything works. And it works completely offline. Everything, it would prevent that from ever happening. My kid would always be happy. And then one of the key fundamental pieces of both this and most progressive web apps is the service worker. Now, this is a fairly straightforward and simple application, it's really just a whole bunch of static files that need to be saved that are available offline. And for most people, this will be sufficient for what you want. Some people will need constant pushing, but the example we're going to go through first is just for caching a whole bunch of resources at once and then having them all available offline. So to dig through it, we just do a few steps. The first one is going to be setting up a prefetch cache, which in this case is a name that's just a string. It represents the concept of a cache inside of our service worker. Caching is a new API. It allows us to save entire network responses as inside of a key value store. So you're able to basically be able to look up whether or not the browser has already cached this network response inside of your browser. So we name it because we can have multiple caches in case you want to be able to, say, have a bunch of content that you cache because it changes constantly, like if you're pushing your own code, and then you have a library cache where things are much slower to update. That way you can blow away one cache and not have to re-download the entirety of your site. Then we set up an event listener for the install event. This gets triggered the very first time you load your service worker in the browser. So this only ever happens the very first time you load the service worker. The next time the user comes to your page, they'll just skip over this completely. So the great part about this step is that allows us to prefetch a whole bunch of stuff that we know for a fact is going to be needed offline, in this case, basically the entirety of the site. Then we dig into the actual event itself. So at the install event, we have this new thing called wait until. See, service workers are not meant to be able to run in perpetuity. They're only able to, the browser only wants to be able to run them for the smallest amount of time possible so that we don't waste the user's battery. The idea of wait until is basically a signal from you, the developer, to us on the browser that you want to give a little bit longer lifetime to this one because you're going to go out and be caching a whole bunch of resources. It's just not necessarily required, just a nicety saying like, please don't kill me, we're doing some important stuff right now. So we say we wait until we open up the cache. So we open that specific cache, in this case the prefetch cache, and it is a promise, so we get a thenable. All these are async operations, and so if you're unfamiliar with promises, it's just a new way to do async operations. Basically, you have a .then attribute where you pass in a function that you get the result from it, from the async operation. So we open that cache, we get a reference to that cache, and then we call cache.addAll. So what that ends up looking like is just a whole bunch of strings. It's an array of strings of all the different URL assets that we want to be able to save offline. In this case, it's just the one asset because the slide only has so much room. That totally rad sans our font. So add all will go through that array. It will make a network request for each individual element inside of that array and then store it into your cache, and they'll all be available offline immediately. We use the new request API in order to do that, and we request them with the mode of no cores. So the reason why we do that is because with service workers, unlike some previous ways to store assets offline, you have the ability to request and cache content that is not from your domain. So stuff like Google Analytics, stuff that's served on a CDN, et cetera. All those things are required for your sites to work while they're offline, but we obviously don't want you to be able to dive in and start modifying your user's Facebook account or something like that. It's a security issue. So the way around that is this mode no cores. What that will do is tell the browser that, hey, we want to be able to get this content and cache this content, but we don't need to modify any of the contents inside of it. So the browser will give you what's called an opaque response. Basically, you'll understand that you have received a successful network transaction, but you won't be able to look at the headers for it, any of the content inside of it, anything like that. Most of the time, this is probably going to be what you want because you will kind of just be able to accept all content. You don't have to worry about whether or not it's from your domain or another domain. You'll just be able to add it to your cache immediately. But if you happen to want to go in and modify some of the content to say, hey, you're offline or something like that, you would need to change that a little bit. In our case, we just have a straightforward caching case, so it is not necessary. So we're already halfway through our service worker. The second half is going to be the fetch event. Fetch is a new event that gets triggered at any kind of network activity in your browser. So this would be when an image asset is requested, when an XHR or AJAX request happens, when basically anything that would ever show up in your network trace occurs, it's going to trigger inside of the service worker a fetch event. So what we do with that event is, that's where we go ahead and cache any new assets or respond to the browser with our pre-cached assets. So for example, when that event happens, we will respond with, we'll go through caches.match. Cache is that same global that we had is the same variable that we had talked about before with the new caching API. .match is a subset where it does exactly what it says on the tin. You give it a request, event.request, which is the actual raw network request coming from the browser. And the cache will go through, the browser will go through your cache and see if you have gone and pre-cached any of that content already. So basically we're saying, hey, do you have this asset cached? If it does, we get a .then, we get the response, the reference to that response rather. If that response is there, we just reply immediately. So we immediately check our cache, see if it's there, and if it is, we reply with that cached asset. If it isn't, we just fall back to the new fetch API. Unfortunately named, it has nothing to do with the fetch event. It's just a new way to do XHR requests. It's a simpler AJAX interface that has promise-based syntax. So we do a new fetch where we pass it the exact same request that we already captured, and it will fall to the network, and we come back and we will shove it into our cache when it replies. So now we have this offline, and everything works. And I was super happy because I could convince my baby to stop crying no matter where in the world we were. And so this is a layout of my apartment. I got it from my vacuum. It's the only way I could think to actually get it working. And so my office is right over here, and the baby's room is over there on the other end. And in Seattle, this is a really old building. It's over 100 years old, which is ancient by our standards. And it's a whole bunch of brick and metal and stuff that doesn't do well with cell signal in between the two areas. And so basically, where his room is almost no cell service whatsoever, no Wi-Fi service. So anyway, I'm going to show off my handiwork to my son, and it works. And I go over and I call Katrina, my partner, up, and she opens up her phone to try and, to do it herself, and she gets this. And that's because of this. See, service workers are not supported in a ton of browsers. They are in Chrome and Firefox. They're coming to Edge very soon. Safari team actually just announced they started working on it, but today doesn't really help my baby stop crying. The service workers aren't on mobile phones unless you're using an Android device, which kind of sucks. So I wanted to have something that could work offline on Katrina's phone as well as my own. And so I started to look into alternatives for how to get content offline. And I found App Cache. If you're unfamiliar with App Cache, you may be familiar with this talk, App Cache Douchebag, by Jake from the Chrome team. And the reason it is called this is because App Cache is a terrible, terrible API. Service Workers is way better than App Cache. In fact, App Cache is so bad, they're actually removing it from the HTML standard. It's one of the only things that has ever been removed from the HTML standard. It's really, 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 really crappy. But it covers our use cases. See, App Cache was built specifically just to cache a whole bunch of static assets, which for me is exactly what I need. And not only that, it's supported basically everywhere. It's been around for a really long time, nearly 10 years. And it has a whole lot of problems, and it has a whole lot of ways that it can hurt you if you don't deploy it properly. You can have problems where you can accidentally cache the app cache itself to where your website would never be updated ever again. You can have to include specific headers that we'll get into in a moment, or sorry, specific attributes inside of your app cache in order to prevent it from thinking it's constantly offline. There's all kinds of ways to shoot yourself in the foot. But if you do it correctly, you can have an okay experience on older devices until service workers are available everywhere. So we want to eventually do something that looks kind of like this. We check to see if service workers are enabled inside of our browser. If they are, we'll go ahead and just register it. And then we just fall back to application cache if a service worker doesn't exist, because app cache is basically enabled on all major browsers. The problem is that app cache, in order to be installed, ends up having to be done this way. Service workers is done dynamically through JavaScript. App cache is done through an HTML attribute, that manifest thing right there. And that has to be there at load time. You can't dynamically append that to the page. It has to be there at the very, very beginning, which is a problem because we want to do it only if the browser doesn't support service workers. If it does, and you load an app cache, you will actually override some of the service worker stuff because the app cache is a huge jerk and constantly takes over a whole bunch of network activity. So the way we get around this is by using an iframe. We create an iframe dynamically, set it to display none so it doesn't actually show anything, set a source to an HTML file that's literally just loading the app cache file, and then append it to our page. So this is the entirety of our HTML file that we're doing. You can tell basically the whole point of it is just that manifest attribute up at the top. And when we append that to the page, it ends up taking over the parent page because app cache will swallow the whole domain if you let it. So this is what app cache looks like inside. Excuse me. At the very top, we have a cache manifest. You have to declare the fact that it is a cache manifest for some reason. And then after that, you just give it a literal list of all the assets inside of your page that you want to have available offline. You have to list it statically at load time. You can't dynamically append to this list. It's one of the many reasons why app cache is terrible. But there's a whole bunch of stuff that you want to be able to add to your page to enable it to work offline, where you know for a fact file name at like your build time when you use Webpack or any other kind of modern build tool. You can output this list automatically and have it function. One of the key caveats to keep in mind, by default, the app cache will think that it is offline and 404 anything that is not a 200. So if it is not able to load one of these files exactly, including like a redirect, it will actually not even allow you to go to the network to check it, even if you are online on the world's fastest internet connection. So we assign this network star at the bottom to basically say, fall back to the network if you think that there's a problem with any of these assets, or if it's any asset that's not included on this page. Now, I can't tell you enough how terrible app cache is, but what's great is that it took the website, the loading on Katrina's phone, down from about 20.7 seconds when we were finally able to get a little bit of tinfoil Wi-Fi in there, down to 190 milliseconds. Having stuff work offline can make a huge and profound impact on your users' use of your website. And so, yes, the API is terrible, but if you are knowledgeable about these terrible old APIs, you can get a much, much better experience for your users until we get the great new APIs everywhere. It is a douchebag, but it's coming. And app cache wasn't even the first attempt at having offline applications. There was many steps before that. Does anybody here ever write a DHTML HTA on Windows 98? Just me? Okay. So if you go to hushlittlebaby.com and IE6, you'll actually get this pop-up that tells you that you can load it as an offline web application where it looks like this. This is something that was built into the really, really early days of Windows. You should never do this. This is nonsense and stupid. It's mostly just because it was kind of fun to figure it out. But the whole point that I'm making is that progressive web apps are not just a radical new way to create new websites. It can also be a radical new way to update your websites. All of this content that I've created up until now could have gone on a website from 20 years ago when we were shipping DHTML instead of Ajax or any kind of Web 3.0 crap. It could have been there the whole time and just never worked because we used proper feature detection, we shipped the features, and it'll only ever light up on browsers that support it, and we still work offline. Another feature that's been around for a really long time that I think is a key part of most modern progressive web apps is the concept of a web worker. Web workers have been around for a real long time as well. They were added to the WebKit project first back in 2008, which is a really, really long time ago. Edge obviously didn't exist, neither did IE 10 or 9. It was IE 8 at the time. Chrome was at version 2. It was a really, really long time ago. Web workers have been around, but for some reason, people aren't really leveraging them nearly as much. Now, if you haven't ever used them or if you're unfamiliar with them, the concept with web workers is that the web kind of has a problem when you're developing for it, and it's that it is single-threaded by default. If you've ever had to create a scroll handler or any kind of heavy JavaScript function inside of your code and the page suddenly gets really janky and gross and slow, this is your problem. It's that everything in the browser has to be executed serially, one by one. You can't have two different pieces of code running at the same time. The reason being that you could modify the entire DOM in one thread and then try to check the value of the DOM in another thread, and then they have a weird race condition and everything's terrible. And as a result, everything is constantly fighting for CPU time. The browser has to wait for all of your code to execute before it can lay out the page and recalculate all the different layout changes it has to make and then paint the page and everything else. And so if you end up having a function that does a whole bunch of calculations or algorithmic changes or anything like that, you get really, really gross, janky pages. And so what web workers allow you to do is to offload tasks to a background thread. Now, these tasks won't have access to the DOM, they won't have access to the HTML, but if you can abstract away that concepts and just have it do the calculations or run the algorithms that you need in a background thread, it can completely save the day and make really, really expensive functionality really cheap. Not only that, they are supported basically everywhere. Pretty much all browsers, with the exception of Opera Mini, which doesn't support anything ever, is back to IE 9 supports web workers. You can have some really, really cool stuff. And for example, I'm the maintainer for Modernizer, the JavaScript library. If you're unfamiliar, it's a feature detection library. It's not super pertinent to the point, but a couple of years ago, we redesigned this page. This is the download page, if you're unfamiliar. And not only that, we actually remade the page so that, or sorry, redid the library so that everything was modular. Before it was just one big file that you would download. Now every single one of these checkboxes or plus signs are individual files that you can click off, so you can build your own custom, really tiny version of Modernizer that's just the needs you want. Now the reason we did that was because people were downloading this whole giant Modernizer file, and they were getting way more code than they actually needed, and we were just kind of bloating the web as a whole. We're the second biggest library after jQuery on the internet, and we felt really guilty that we were responsible for slowing down users' websites. So what we did when we were creating this was modularize it, and then also build a little ticker in the upper left-hand corner that told you exactly how big your build was dynamically and client-side, and that includes both the full file size and the gzipped file size. And so as you tick stuff off, you'll actually get updated values immediately without ever going to the server. The way that we did this was by using a web worker. We actually just built everything client-side inside of a web worker, passed it over to another web worker where it calculated the entire length of the file and checked inside of a JavaScript implementation of gzip, and everything was completely done. And if the browser didn't support web workers, if there was ever a problem with the code, we just didn't have that piece of functionality. It's just a progressive function that we added to our page. Another project that I've been working on is this thing called the web worker preprocessor. It's a collection of JavaScript files that have been created by transpiling external template stuff. So stuff, if you ever use like CodePen or JSBin or anything else like that, you've seen stuff, projects like the Less library, Slim, Pug, Jade, even Sass and Haml, Ruby projects that have been completely written in other languages. We were able to transpile all these projects over to JavaScript and have them run inside of a web worker. So you could have a offline PWA with something like CodePen or SassMeister or JSBin, any of these sites. You can check it out at the offlinesass.club. It's just a stupid little website that I made. And if you go there, excuse me, you will have the ability to modify stuff on the one hand, hit compile, and have the entirety of the Sass library running inside of your browser and update it dynamically. It's kind of a dumb website, but it can show that you can actually bring external libraries that were never intended to run inside of the browser, whether they be Ruby, C, JavaScript, or Rust, or any other language, and have them run at high speeds because of web workers. Facebook actually loads libjpeg, the canonical JPEG library, inside of a web worker. It's been transpiled from C into JavaScript in order to resize photos that users upload, because users tend to upload extremely large files if they're photographers, something like 200 megabytes. They resize those all the way down before they even upload them. That way users on slow connections or Facebook's own traffic content can be reduced as much as possible. People are using web workers at these really high-level websites and really important websites, and you can check them out for your own projects and just do completely crazy stuff. Another great example, one of my coworkers, Nolan Lawson, created this website called Pokedex.org, which is another silly website. It's just a way to list all of the known Pokemon. But he wanted to make it extremely fast even on old devices. So he used a project called Virtual DOM, which is effectively just the core tenet of React. It's this concept where you keep track of what the layout of your page is in memory, just a DOM object, and then compare it against the current one. So whenever a change happens, whenever like a user clicks a button to expand something, you do that against the virtual DOM, your main DOM, you diff the differences, and you're able to calculate the smallest amount of changes possible to get to where your user wants to be. He extracted that into a web worker so that you have all this content being, all the heavy algorithms running inside of a worker and not blocking your main thread. And as a result, he was able to get over 60 frames a second on, this is the Nexus S, which is a phone from 2011. And it's renders faster than most of the this video isn't really doing it justice. You can check it out yourself. But you can have incredibly fast performance on devices that are much older than my child, and frankly, that's impressive to me. You can check out the project here at github.com. It has a lot of cool little performance tidbits. Nolan's actually one of the performance leads for the Edge team, and so he really, really knows his stuff. You might be more familiar with Nolan from IndexedDB. He's also the lead for a thing called CouchDB, which is a full version of the CouchDB database that runs inside of a IndexedDB inside of the browser. So you're able to clone the entirety of your database and keep it in the browser. It's built on IndexedDB in the best cases. It falls back to other database formats if you don't have it. But IndexedDB is another one of those things that should be used more on the web, but isn't for some reason. I don't know if it's a lack of education or if it's just kind of difficult, but it's been around for a really long time, since 2009 when it was added. And honestly, I say I don't know why you don't use it more, but I kind of know. If you've used local storage, it's one of the easier to use storage items. You're familiar with kind of this interface where you have a key value store, and then you get the item later on by that. To implement the exact same thing in web SQL, in IndexedDB, looks like this. And this isn't a joke. This is actually to do the exact same key value store in IndexedDB. It's terrible. It's terrible to write easily at the very least. But that doesn't mean you shouldn't use it. There are a lot of different storage methods that are available to the web and that you can build off of. But IndexedDB is really one of the largest and most worthwhile databases. And if you've been scared off by the syntax, you should check out some of the libraries that actually make it a lot easier. One of my favorites is Dexy.js. It ends up taking IndexedDB and turning it much more into like a jQuery-like syntax, where you're able to have this kind of streaming interface over the API and pluck and pull and do all kinds of much more readable interactions on top of IndexedDB. If you want a local storage, like interface, there's local forage, which gives you the exact same local storage API, just slightly differently. You have a callback interface instead of it immediately returning. There's also, of course, PouchDB, which is the one that I mentioned, where you have a full CouchDB instance inside of the browser. And what's great about IndexedDB compared to a lot of these other libraries is they actually can give you gigabytes of storage inside of the browser, and that is gigabytes with a G. Chrome and Firefox will give you up to 50% of available disk space on the device inside of IndexedDB. You can store large forms of media, videos, audio, all kinds of stuff. Edge stores hundreds and hundreds of megabytes by default. It can be included. If you want to check out all the different ways that you can abuse storage, you can check out the browser storage abuser at this domain, and that will show you all the different ways where you can keep a whole bunch of data offline. You can store the entirety of your website probably several times over inside of a user's device without them even noticing. You can be caching and pushing the boundary on what content is really possible on the web by leveraging stuff like IndexedDB and some of the new storage APIs. Now, all these different storage methods have been around for a really long time, and they're not necessarily always viewed as fundamental to progressive web apps, despite the fact that I do. But one of the things that absolutely is key to a progressive web app is the concept of a web app manifest. This has nothing to do with the app manifest or the app cache manifest that I mentioned before. It's a new specification, a couple of years old at this point. It originally came from the Firefox team when they were building Firefox OS, but despite Firefox OS no longer existing, the spec still does. And it's basically, if you've never written any kind of native application or Chrome extension, you'll be familiar with the concept of a manifest. It's just a big JSON blob inside of a file that is just a whole bunch of metadata about your application. Stuff like title, the language of the thing, the text direction, description, so that when Google or Bing come to it, can give you your users a nice description of what it does, all the different icons for all the different types, and a whole bunch of other assets. You can even have some cool features like related applications. So if your company ends up making a native application in addition to your progressive web app, you can actually have it tied to it inside of this, and then automatically load the native application if a user ever opens up your website or PWA instead, and that can be controlled with this prefer related applications flag. By default, it's false because the web should win. Yeah, and what's great is that in order to support it, it's really just this. It's just a link tag that you can add inside of your HTML. And that could have existed 20 years ago. In order to have that Hush Little Baby website work, I added the web manifest to it, and that could have been there back when HTAs were still a thing, and it wouldn't have changed anything. You can start shipping this today, and you might be wondering, or you might have noticed rather, a whole bunch of that content that's inside of this manifest is also inside of the header already, and it's kind of constant header bloat. One of the aspects of the manifest is being able to abstract all that different content from your header, put it into a single cacheable file rather than having to constantly expand it with more and more new icon formats. But the great thing is that this actually makes it really easy to get onboarded with a manifest. I actually created a node module called manifestation. What this does is it takes a URL and it will crawl that URL and build the most fully featured web manifest file possible for it so that you can start building your own PWA today. And I do mean fully featured. It goes pretty all out. This is one of the language detection ones, which is honestly probably the simplest of all of them. We end up loading A couple of node modules up at the top. Cheerio is a server-side jQuery replacement. CLD is compact language detection. It's a binary file that's able to parse a huge chunk of data, a huge chunk of text in order to look for the most commonly used language inside of it. It's what Google Translate's built on top of. And what we do is we end up loading the HTML of the page, the URL that you give it, and we check for the simplest language attributes. If that doesn't work, we fall back to the HTML, XML language attributes. If that doesn't work, we fall back to Dublin Core, which is a format only used by librarians in the 70s and 80s. But I told you, I want it to be fully featured. So if you declare a language in any way, we will find it. And if you don't declare a language, we pass it over to CLD, it parses the whole content, and then we get that value. And like I said, that's one of the simplest things. The icon one could take 15 slides to go through, but we find every single kind of icon that you possibly exist on your page. Obviously your favicons, your Apple Touch icons, your MS Tile application icons, or even your MS application config. If there's a way to declare an icon, we'll find it and we'll put it in your manifest for you. Now, I wanted to make this as easy as possible, so we ended up making Web Manifest because I love novelty domains. You can go to that website right now, and you'll see this. It is just a single text box that you put in a URL, you hit enter, and you will get a download prompt for the Web Manifest. You can add that to your website today, and you'll be on your way to making a PWA. It's a really easy way to get started. If you're interested in the Web Manifest spec, here's a couple of near short URLs that are on top of that domain, the validator and the spec itself. You can check out some stuff. And yeah, it's a really, really easy way to get started. And what's great about it being so declarative in this manner is that it makes it really, really easy for content owners content searchers rather, like Bing and Google to find it. And so one of the really cool projects that the Bing team is working on in conjunction with the Edge team is crawling the web, looking for websites that declare a web manifest. And if it is, they're going to be automatically ingested into the Windows Store. So this will obviously be able to be opted out of if you don't want to have your content on the Windows Store. But by default, we will go ahead and find any website that's declaring itself as a progressive web app by including a manifest, and we'll be able to expose them to the hundreds of millions of people that go to the Windows Store. So it can be a way to expose your content to a much larger audience without you having to lift a finger, other than to go to Web Manifest to create one. It is a kind of an interesting future with progressive web apps, especially because you want to tailor these applications to feel like they are natural, to feel like they belong on whatever platform the user's using. But at the same time, we don't want to go back to the days of Best Viewed and IE4 or Netscape 2 or any other thing, right? We don't want to make websites that actually only ever work on one platform. And so when we build our progressive web apps, we want to be able to take advantage of whatever native features are available on that platform without necessarily building stuff that rely on it. A great example of this is a lot of the ELECTRON work. By default, ELECTRON wants to look like a native application, so the user doesn't know that it's a native application, doesn't know that it's not a native application. If you've ever used a Java desktop application from 10 years ago, you'll know it didn't really feel like a Windows application or an OS X application or anything else. It kind of just felt like a Java application. And one of the ways that ELECTRON gets around that problem is by leveraging and making sure that all the ELECTRON apps have their own non-custom system-based close bars. That's a great example of leveraging whatever the system provides already in order to give you a good experience. And that's something that when you're building progressive web apps, you want to be able to take advantage of any of those features available. A great example would probably be Safari push notifications. By default, Safari Desktop has actually had the ability to do push notifications since 2011. Not a lot of websites do it, but if you have a website, it's something that you can consider. It's pretty easy to set up, and though it is non-standard, it is something that's coming to the web as a whole. If you have a lot of traffic from Safari Desktop users, you are able to give them a better experience, theoretically, by leveraging a lot of these APIs. And eventually this actually did come to the browser. It's already shipping in Chrome Desktop, and it's coming to Edge in Edge 16, but you could have been using it for years now, and you could have kind of honed that experience before more of your competitors are able to use the exact same APIs. Web payments is another example. Safari shipped the Apple Pay on the web last year, and where you're able to have near seamless checkout experiences without having to mess with any of the user's credit cards or store any of their financial data. It's handled completely by a JavaScript library and Apple's communication servers, and it works really, really well. I come from an e-commerce background, and everyone's tripping over themselves to get Apple Pay enabled on their website because it means that the user doesn't have to fill out forms, they don't have to upload new contact information or new credit card information, they just put their finger on their device and it works. It's great, and it's something that a lot of people should be using. But at the same time, we also have the web payments, something that's been coming to Edge over a year ago now, that can hook it directly into the Windows Store wallet. See, the point that I'm trying to make is that you should be willing to use these cutting-edge APIs even if they're non-standard, because it helps give signals to us at the browser what people care about. If a whole bunch of people start using these Apple Pay or other non-standard payment APIs, we'll realize that y'all want an easy way to do web payments. And obviously in this case we already knew that and we built it, but the more that people use these APIs, the more you can signal to us on the browser what you want and what you want to be made better. And this API is actually really straightforward to use. You just have to define what supported information you have inside of your web payments. In this case, we're just wanting a basic credit card to define the types of credit cards that we support inside of the network. And then we also just give a couple of details, like what's the total amount due, what's the country that the value is in, and the value itself, and then whether or not we want a shipping address. And then we just do a new payment request where we pass in that metadata inside of it with our feature detection, and then if that feature detection fails, we just forward them over to our old checkout experience. And this is just a progressive experience that makes people that are on the more modern browsers have a much more enjoyable experience. By leveraging these new and cutting-edge APIs, you can have a much faster and much more financially beneficial experience for you and your users. This is actually also shipping in Chrome as of a few weeks ago on both Chrome Mobile and Chrome Desktop. So it's definitely something, if you in any way take money on the web, you should be checking out web payments. It can definitely make it a lot better. And one of the great things with that thing that I mentioned before, the fact that progressive web apps are going to be coming to the Windows Store, is because of a quirk of the way that they're packaged, ends up effectively meaning that they're really just packaged web applications. If you've never built a Windows native application, it's just a term that we use to basically mean a Windows native application that really just loads a website inside of it. And as a side effect of that, if you happen to have a user that installs your progressive web app on the next version of Edge that's coming out, you will have access as a developer to the entirety of the WinRT API. So you'll actually be able to do feature detection for if window in Windows, and then access stuff like the device's Bluetooth. You can be able to control and interact with the user's Bluetooth with their permission, of course. They'll be prompted and told that you're doing it, but you can have a lot crazier of a thing. You can do stuff on a website that you never thought possible before, even just a few years ago, with ease. Media keys, you're able to hook into the play and volume controls. If you have any kind of video or audio on your website, you can hook into the hardware controls in order to support that. Even OCR, optical character recognition, so that you can detect someone's, if they're taking a photo of content, to be able to more quickly fill out a form or any other kind of content. You can build on top of the native APIs that already exist using an easy-to-use JavaScript API, or even Cortana. You have access to the entirety of Cortana. You can include your own cards or do all kinds of system leveraging stuff with it. And you can use all of these cutting-edge APIs because you shouldn't be waiting for any kind of a re-architecture when you're thinking about building a progressive web app. These are progressive concepts. You can start just kind of folding them in over time. You don't have to wait and do a complete build from scratch. You can just start adding features like the manifest today in ways that won't negatively affect any of your users, even if they don't support them. You can slowly fold into it and get something, and just don't be afraid to use any of this new shiny stuff. It's fun, and we promise it probably won't hurt you. And just make awesome stuff. That was it. You can check out any of my stuff here. I'm Patrick Kettner, basically anywhere. If you have any questions about Edge or anything else, feel free to email me, patcat@microsoft.com. Thank you. If you have any questions, anybody? Cool. I have stickers. If you want to ask questions in private, I'll be up here for a little bit. Cool. Thanks for having me.